Hello dear friends, welcome to my channel. Today's discussions is complex analysis. Consider the function f defined by fz equals to 1 by 1 minus z square for z belongs to c such that 1 minus z square does not equals to 0. Which of the following statements is true? F is an entire function. F has a simple pole at z equals to 0. F has a Taylor series expansion expansion fz n equals to 0 to infinity n z equals to 0 z to the power n, where the coefficient n recursively. Okay, this is the Lorentz Taylor series also included. So first question is that f has a simple pole at z equals to 0. This is wrong, because friends, if fz equals to 1 by z and something, okay, in this case z equals to 0 as a pole. Okay, so z equals to 0 as a simple pole, this is not correct. Another case is f is entire function. So friends, f is entire function means it is analytic function. Okay, z belongs to c. So in case when I can say 1 minus z square equals to 0, then I get z equals to alpha and z equals to beta. So I get 2 point where it is not analytic. So f is an entire function. This is also wrong. Okay, so next case is f has a Taylor series expansion fz equals to n equals to 0 to infinity n z to the power n, where coefficient an recursively defined as follows: a0 equals to 1 and a1 equals to 0, an plus 2, an plus 1. Okay, c and d, you can check. C is, in case of c, a1 0 and a0 equals to 1. Okay, and in case both are a0 and a1 equals to 1. So in this case, friends, I need to say, I I have to express 1 divided by 1 minus z square is in this term, an z to the power n, Taylor series term. So how can I write? Suppose my equation is fz equals to my equation, okay, 1 minus z square. Okay, so I can write this way: 1 minus z minus a and z minus b. Okay, so no problem. So I can write this way, that it can be written as a gamma. Okay, alpha a minus b is equal to, suppose, gamma. So I can write this way, that minus 1 by a 1 minus z by a minus 1 by b 1 minus z by b. Okay, so this way I can write. Now it can be written 1 by gamma equals to minus 1 by a 1 minus z by a whole to the power minus 1 minus 1 by b 1 minus z by b whole to the power minus 1. Okay, so this is the total you can write, and you can explain this is as a Lorentz series. How you can write Lorentz series? Lorentz series, because must remember that mod of z by a equals to less than 1 and mod of z by b less than 1. So this is the explained as a Lorentz series, geometrical series, and this is the possible when minimum a comma b b should be our domain. Okay, is omega in this region mod z mod z should be less than omega. Okay, this is the when then Lorentz series exist. Okay, so Lorentz series exists. Now friends, our question is that Lorentz series when exist, so how can I write this? We need to know that what is, we need to know Taylor series. Okay, Taylor series when fz equals to, okay, when fz equals to summation a n z to the power n equals to 1 to, so we can write this way, that we know the Lorentz formula. What is the formula? Coefficient a n is equal to Lorentz formula f n 0, okay, fn0 divided by n factorial, fn0 divided by n factorial. So this way you can get, that a1 equals to f dash 0 divided by 1 factorial, and f dash z equals to, at first I have to do the derivative, so 1 minus z square whole square and 1 plus 2z. Okay, it can be written, and f dash 0 is equal to 1. So a1 is equal to 1, easily I find out. And now I have to check that a0 value. Now you can check the values of a0. A0 value is very simple. A0 is equal to 1. And another way you can get, very simple way, that 1 divided by 1 plus z square equals to summation n equals to 0 to infinity a n z to the power n, and 1 is equal to a1 a0 plus a1z plus a2z square plus up to infinity, and into multiply 1 plus z square. So this way when I multiply, then we can check a0 is equal to 1, and we see that a1 plus a0z equals to 0. Okay, okay, this is not minus, this is not plus. In here I have this minus, so a1 minus a0, so a1 equals to a0, that is 1. So my option D is correct. Option D is correct. Next I will go next problem. Next problem is based on Schwarz theorem. Okay, Schwarz theorem. I believe that we know everyone the Schwarz theory, but again I will discuss, because I have already discussed Schwarz lemma. Okay, Schwarz lemma in my complex analysis video. When people want to check, then they can find out that I discuss Schwarz peak theorem. Yeah, Schwarz peak theorem problem. What is the problem? That mod of f dash z less than equals to 1 minus mod of fz divided by 1 minus mod z. Yeah, I think that you remember this formula. Which formula is Schwarz Schwarz peaks theorem. Okay, Schwarz peaks theorem is, I know, less than equals to, just recalling, yeah, this I know that this is not important for in here, but I just recalling that this formula is also important formula. Okay, so fz whole square and 1 by z whole square. This theorem we know Schwarz-Peak theorem. Okay, Schwarz-Peak theory. Now as Schwarz lemma. Okay, we discuss Schwarz lemma. So what is Schwarz lemma? In case of Schwarz lemma, I can say that mod of fz less than 1. Okay, it is the very detailsly explained in the book. If you check in your book, then book you can get that what is the Schwarz lemma is well defined. That I am just telling you that what is Schwarz lemma. Schwarz lemma is Hermann Amadeus Schwarz. Okay, and that named Hermann Amadeus Schwarz is a result of complex analysis about holomorphic functions open unit disk itself. So let's start to discuss what is Schwarz lemma. Let d equals to z such that mod of z less than 1. Okay, you see that Schwarz lemma is important, less than 1. So in here less than half, so obviously mod z is less than half, so it is obviously less than 1. Yeah, this is the formula. Be the open unit disk in the complex plane C. Okay, centered at the origin, and f such that d tends to C, be a holomorphic map. Holomorphic map such that f0 is equal to 0, condition f0 equals to 0. That this condition is also hold in here, f0 is equal to 0, and okay, and fz mod of fz less than 1. You see the domain is the same, mod of z is equal to range limit is mod of fz. So this is the correct. On d, then mod of fz less than z, mod of z for all z belongs to capital, and mod of f dash 0 less than equals to 1. So mod of fz is equal to z, then if mod of fz equals to z, if in the case of if, then equals to mod z. Okay, I can write for some non-zero z f dash 0, then fz is equal to az for some a moreover. Okay, mod of fz is equal to z for some non-zero z, then mod of f dash 0 equals to 1, then that implies fz equals to az for some a belongs to C, and mod of a So friends, you see that this is the total solution. Okay, Schwarz theorem I will apply. Schwarz theorem hold, because you see f0 is equal to 0 and this is the less than half, so means it is the z less than mod of z less than 1 and holomorphic. Okay, so you get everything is same. Okay, so friends, now my the first questions that mod of fz for all z when mod z less than 1, this is true. Obviously this is true by Schwarz theorem. Okay, by Schwarz theorem this is true. Now friends, another question is that f of z is equal to mod z, this is true. Now my question is that f of mod z is equal to less than mod of z by 2. This is correct or not? This is correct or not? These questions. Let we can say phi z. Okay, we can take phi z. Phi z equals to 2 fz. Okay, phi z equals to 2 fz. And now mod of phi z. Okay, mod of phi z, you see mod of phi z. Okay, according to the questions, what is the Schwarz theorem? Schwarz theorem is say that less than 1. Okay, mod of fz less than 1. Yeah, holomorphic and fz less than 1. So, mod of phi z equals to 2 of mod of fz. Okay, so 2 of mod of fz. So you see that this value is equal to 2 into half. Okay, equals to, so I can write that mod of fz, mod of phi z less half. Okay, you can say a lot of phi z equal less than equals to half. Okay, now it is clear. Not sorry, not clear, not is equal to 1. Okay, less than equals to 1, not half. So when mod of fz is less than half, so I can write phi z is less than 1. Okay, as the range set is codomain, it is given that codomain, you check that codomain according to the questions, codomain is less than half. Codomain, this set is called codomain. Codomain is less than the true. This is true for all. So mod of phi z equals to 1. Okay, for all, so for all z belongs to d. So I can write that phi z according to Schwarz lemma, phi z equals to z. So 2 fz equals to z. So fz equals to z by 2. Okay friends, I hope it is clear. So fz equals to, I can say mod of fz equals to z by 2. This is correct. And now mod of fz less than equals to half. Okay, mod of fz less than equals to half for all. Okay, for all mod of z less than 1. Okay, this is possible or not? Okay, so this case, if we use Schwarz lemma wise, mod of fz less than equals to z. Okay, if I use Schwarz lemma, so half, when half is the range set. Okay, range space is half. Okay, range space is half. So I can say that this is possible for all z in z such that it can be possible. Now the second question, third is, it is possible if half is equal to half. Okay, if half equals to half is possible or not, that I will explain the Schwarz equalities. Schwarz equality is Schwarz, Schwarz inequality. Schwarz inequality say that Schwarz inequality say that mod of fj, all the conditions satisfied, that mod j is equal to domain. So when it is inequality hold, you see fj equals to az. Okay, f dash 0 is equal to 1, so f dash z equals to az. Now I can write if half equals to a, where a mod of a equals to 1. Okay, where mod of a equals to 1, so I can mod of a into half. Okay, a into half, and mod of a equals to half. Now next, this is the very careful, please pay attention, that how I want to say that if a is equal to a into half, suppose a equals to, if we say suppose a equals to 0.99. Okay, 0.99 up to dot dot. So in this case we see that, in this case we see what we see that it is the out of the range, out of the codomain, mean this codomain is equal to half mod of z, mod of fz less than half. Okay, so if my a is equal to 0.99, because mod of fz according to the question equals to az, so 0.99 z is equal to half, so half into 0.99, it would be exceeded. Okay, so in this case, okay, it may be epsilon is equal to 1. Okay, epsilon, mod of epsilon equals to 1, so z equals to 0.99. Sorry, z equals to, when j, in the case of z equals to 0.99. Okay, in the case is equal to z equals to 0.99, then it is not possible if half is equal to half. So this portion is wrong. It is possible that if half is equal to half, no. Why? Because the Schwarz theorem, fz is equal to epsilon z. Okay, fz equals to epsilon z, epsilon or az, where mod of a equals to 1. So f half, when we put that f half is equal to epsilon into half. F half is equal to epsilon into half. Epsilon into half. Now fz is equal to 0.99. Z, suppose z equals to 0.99, then it is outside of the codomain, because f has the d bar. Okay, next friends, next is the, let f be a entire function that mod of fz less than equals to e to the power I y. Okay, mod of fz equals to e to the power y. So e to the power y, so z equals to, suppose z equals to cos theta cos x. Okay, cos theta plus I sin theta, I can write simple way. So z equals to I sin theta and cos theta I sin theta cos theta, cos theta I sin theta. So fz is equal to c into e to the power yj ij. I have to prove these equations, this is hold or not. Okay, so e to the power y, I can say z equals to a cos theta sin theta, it is very good, x plus iy. This is my formula. Okay, so fz mod of fz is equal to c into e to the power minus I x plus iy. Okay, so de Moivre's theorem, we have to remember de Moivre's theorem is, it is the c mod of c cos minus x plus I into c sin minus y. So and another is multiply, is e to the power y is multiply. Okay, because it can be written as mod of c e to the power minus ix plus y, and e to the power y is outside. Okay, okay friends, so now we get c into e to the power y, and cos x plus I sin x mod is equal to fz. Okay, so c into e to the power y and mod of c less than equals to 1, so mod of fz less than equals to e to the power y. So my these equations hold. So my first option A is correct, and second option fz is equal to c into e to the power iz, this option is not correct. How friends? Because we see that option B, if we putting the value, then mod of fz we see that less than equals to e to the power minus y. Procedure is same, minus I into x plus y minus ix, and I square minus I, so minus minus plus. Okay, if I write x minus iy, so it is plus iy minus iy, it would be, so e to the power minus y. So everything is changed, just the sign changing. Okay, just sign change, keep the sign changing, just change the sign. Okay, so whatever I get this is the minus and minus minus plus, and sorry, not minus minus plus, minus minus plus into I means minus e to the power minus y. So this is not possible, option B. So option B is not correct, and option C is not correct. How option C is not correct and D is not correct? Procedure is same. We get whatever we get for option C, mod of mod of fz is equal to e to the power minus c I into x plus less than equals to e to the power minus c. Okay, mod is also given, so c into I x into c y, so we get it is e to the power c y. Okay, e to the power cy, similarly e to the power minus cy. So if we can see that this option is not correct. So I hope I can clear total solutions. Please check my total work. Now friends, please check my total work. Hope it is clear for everyone. I think that you can understand. Thanks for watching.